Hello. Um, wow, I totally forgot how to stop this thing. Uh, hey, how's it going? I think, can everyone hear me okay? Just hit, thumbs up in the Slack channel or thumbs down. This is my first time doing a big kind of stream like this. I've done streams before, but this is the first one that I've had people actually watching. So it's a big change, and I'm really excited to be doing it. And I'm also really excited to announce that this is the first Rad Lab. Rad Lab is Studio Lab's new weekly workshop series, and we're going to be doing one every single Wednesday at 8 p.m. And we think 8 p.m. is kind of a good time because we want people on the East Coast to tune in after dinner and people on the West Coast to tune in before dinner. And even if you can't tune in, we're going to be posting these videos to our YouTube channel after they're done. So some of you may have noticed that I'm streaming from the Coding Caboose, which is kind of a weird YouTube channel. That's actually that's my personal account. I privated all the videos because anyway, we'll talk about it later. But um, the next time you watch, we'll be streaming from the Studio Lab YouTube channel. And so yeah, that's kind of what's going on. I'm Brendan Byrne. I'm the Studio Lab manager, and Cynthia Vu, who is one of our interns this summer, has been helping me, and actually I've been helping her put together this series. We really miss being in the Studio Lab and working together and doing projects together, and so we wanted to create a kind of low stakes, low pressure environment where people could very easily just share something that they've had for a long time and they just want to they just want to get it out. It doesn't have to be polished, it doesn't have to be super fancy, it just has to be something that you know a lot about that you can talk about in 15 to 45 minutes. We're flexible. I'm a little worried because now that I've kind of shown you what the synthesizer does, it's like, whoa, that's really cool. And to be honest, like I kind of forgot how cool it is, because it's been sitting in my closet for 3 months, and before that, it was sitting in another closet for another 3 months. Um, there's there's a lot to get to know about me, but I'm very much like an ambivalent designer. Like I really like making things, and I really like um, you know building things and making them work. But then once they're made, I'm really just kind of like, okay, let's do something else. And recently, in the past year or 2 years of my life, I've really discovered that I like working with people, working with students, helping them with their projects much more than I like meticulously designing electronic circuits, in front of a computer all day. It gets lonely pretty quick. So this project is really just kind of not gone anywhere for a really long time, and I kind of forget about it. But I'm really happy to share it with you because it is, you know, my my biggest project, and I've been working on it for about 7 years. Yeah, I think if we have any grad students tuning in right now, I think you all are familiar with the project that just like seems to haunt you, but also seems to be the thing that you're just like totally excited about and can't get away from. This is kind of my project that haunts me, that I'm really proud of, and at the same time have a lot of ambivalent feelings about. Um, so yeah, I don't really know where to begin. I hope people saw the demo that I gave, and if you didn't, we'll post the YouTube video later. It turned out pretty cool. That's really a fraction of what this thing can do. I basically like real tip of the iceberg situation. What you heard was just this module up here and this input kind of, oh gosh, I haven't talked about this thing in a long time, but this input interpreter. So it was just those two things making all of that sound. We've got all these other modules that perform completely different functions that are unique. And then there's a lot of kinds of bells and whistles over here that you can use to modify the behavior of each module. And then you've got four different inputs for instruments. So what you were just listening to was only one instrument. You could have 4 instruments going at the same time, each with their own separate controls, each with their different sequences and patterns and triggers and, you know, cutoffs and possibilities. It's complicated. You know, when you work on for something for 7 years, it just builds up and you don't even realize it. And so I'm really not sure where to take this presentation tonight, because I could either, you know, talk about the history, which is kind of interesting, and, you know, what it means to design something like this as an amateur. You know, I don't have an electrical engineering degree, and I'm not a great programmer, but I was trained as a designer, which is kind of like, you know, why did I get interested in synthesizers? Well, they sounded cool, and they also like looked cool, you know, above anything else. Like, I was very much interested in just like how cool these things looked, like flashing lights, buttons, you know, things you turn, and like slide pots. You just want to like do something with them. And so I was always very interested in just like building these things for just the way they look. But let me just back it up a little bit, because like, how does this thing actually work? As far as I know, there isn't really anything else out there that works this way. So let me see if I can switch screens here, and I'll show you the first version that I made back in 2013. Well, actually, let me tell you about one of my mentors when I was a young designer in the city, yeah, in New York City. So this gentleman right here. Oh, let me switch screens. Here we go. So this gentleman right here is Phil Stearns, Philip Stearns, and let's see, he's an incredible person. He's taught me so much about dedication to your work. He's pretty much the person who made me realize it wasn't like super dedicated to my work, and that you know, I should probably do something else. He's like one of the few people that I know who makes his entire living off of making work. And I knew a lot of artists in the city. And he made it happen. Every day was like a struggle. And so anyway, Phil's a great person. He always helped me with the work that I was doing, and he was always encouraging. And I actually kind of took one of his projects and changed one little thing about it. So what you see up here is this this synthesizer that he designed. When you think of synthesizers, you think of the big Moog type deal. Let's see if we can pull that up. So Moog synthesizer, like Rick Wakeman, or I don't know, that like switched on Bach. I mean, just really stellar, soaring kind of melodies, Kraftwerk, Yellow Magic Orchestra, those kinds of sounds. And sometimes they're modular. You have patch cables and you connect them all together, and that was all really cool. But Phil did something kind of different, and he also built on the work of others as well. But this is a CMOS synthesizer. It basically uses exclusively on and off messages to generate signals. A traditional synthesizer uses waveforms. You've got sine wave, you've got triangle wave, and you have square waves, but this only uses square waves, and that's because the chips are only digital. They're basically like used in computers to control, you know, memory being shifted around the board, input commands being interpreted by a microprocessor. So they're really meant to work within a computer, and because of that, they're meant to work at like a very high rate, a high frequency, a frequency that's fast enough to generate audio signals. So you get kind of like a buzzing sound, or like because it's a square wave. You know, it's turning on and off very quickly. So it sounds a bit like a Nintendo that's out of tune. Phil, every time I saw him, he made this synthesizer bigger, and it was so cool. And one of the things he had in it was a step sequencer that basically was just like any other chip, except it operated at a slower speed that allowed tones to kind of be generated. So you'd have like beep, boop, beep, boop, beep, boop, that kind of thing. And if you had sped something like that up, it would have generated just a solid pitch. I'm sorry, this is getting kind of technical, but I haven't talked about this in a long time. I hope it's coming across. Maybe I should have had more visual aids. So Phil was using this audio synthesizer, and I was like, I want to make something like that. So I'm in grad school, and I'm trying to impress all my professors, and I'm like, well, let's go for it. Like, I'm going to basically do what Phil did and like use this as a learning experience. And I'm sitting around, I'm trying to do it, I'm like, gosh, this is complicated. And I was like, wait a second, what if I just slow the whole thing down and use it only for music generation? Music not in the sense of like audio sources, but notes, messages, patterns, basically. Like if you think about a player piano, like what if I use these chips not to generate the sound that the piano makes, but use it to generate, you know, the holes that are punched in the piece of paper in a player piano. And that became really interesting because behind each one of these chips is like, you know, a pattern generator, and you connect them all together, you generate interesting patterns very quickly. And I'll talk about that a little bit more in a second. So I was just like, wow, this is great. And also, it's not very difficult to do with my limited skill set as just a designer. So yeah, I took a stab at it, and what I made was something I called, what did I call it? I mean, I call it the CMOS Logic Modular System, but everything you're going to see tonight's Destiny Clock. I just called everything Destiny Clock. It's such a cool name. I just like couldn't get away from it. But this uses those digital logic chips I was telling you about at very slow speeds. So every time you see a light turn on, that's actually the signal being generated by the actual chip. This isn't programmed. There's no programming in this module. It's all the chips doing the things that they normally do. So the module all the way on the left here is just what's it called? An oscillator. Yeah, on and off. It just generates signals at a constant rate, on and off. I mean, not a perfect rate, but close enough to get the job done. Then this thing called 4040. 4040 is actually the name of the chip. 4040 is a clock divider. It takes an incoming signal like ba, 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 and then slows it down by half, ba, ba, and then slows it down by half again, ba, ba. And with those outputs, you can combine them in different ways to get some pretty interesting sounds. We'll see in the video in a second. The other thing over here is a shift register. I'm not even going to try and explain that. I mean, hopefully someone on this viewing this video is like, I know what that is, and like, thank you. Okay. Maybe for a completely other video, we could do a whole rad lab on what a shift register is, or really any of these chips. And then over here is just a multiplexer. It basically takes one input and then uses a series of other inputs, and dependent on those states of those inputs, you route that input signal to one of 4 or one of 8 outputs. So like if none of them are on, then it goes here, and if this one's on, then it goes here. It's kind of complicated to explain. It's simple. It's like once you get it, you're like, oh, obviously. But then the second you have to like explain it to someone without any visual aids, you're kind of like, oh. Okay, so the last module over here on the right is like an Arduino, and the Arduino is using just something like a very simple like digital read message. Basically, each one of these inputs is like a push button. Like if you can do the push button sketch in Arduino, which is the first thing that you can do it within 5 minutes of buying an Arduino, or not buying, but like opening the package and plugging it in. 5 minutes later, you're doing what these inputs are doing. So instead of looking for a tactile button press, it's looking for like an electrical signal, which is being generated by one of these modules somewhere upstream. And the sound that this created was interesting. It was effective. It got the point across, like mission accomplished, but it was still difficult to work with. So in this example that you see, I kind of like cranked up the speed high enough to get a more interesting sound. So I'll just play that real quick. And you can see it's like actually, you know, it's kind of interesting. This is using a digital protocol called MIDI, which I hope some of you are familiar with, but it stands for Musical Instrument Digital Interface. And it basically, you know, if you think about, you know, like your keyboard or something, it's sending digital information to your computer whenever you press one of the keys. MIDI is over 30 years old, and what it does is it allows you to have many different pieces of digital or analog, I guess just digital synthesizers and music equipment communicate easily with one another. So you could have your drum machine sync to your step sequencer, to your analog synthesizer, and when you press this button, they'll all start at the same time. So this is using a very old protocol that's a little dated. The resolution is quite small. It's 7 bits, so it's even less than like a Nintendo. It's limited, but its impact has been profound. Almost every electronic musical instrument you'll see has MIDI built into it. Like with a MIDI interface, you can communicate with any instrument. So this is just kind of, you know, it's neat, it's quirky, it's like proving a point. But I was a little disappointed because, okay, so I see Cynthia's question, enemies and friends. So you can have, if you have it set to friends, all 16 of these steps can go in order, or if you switch it to enemies, you can have 2 separate inputs. So it would go like this way, those 8, and then these 8 would function independently of one another. So I was just, I don't know, I was like a quirky grad student when I was thinking about that. So the thing with MIDI is that it's just like a digital thing. It doesn't, you can route it anywhere you want. You can route it to sound, you could route it to synthesizer. I've done text output with MIDI, but I also want to share that I plugged this into a sketch I made in processing. This is my dog, Ozma. Ozma. This is Ozma. It's a good girl. Ozma's really interested in screens, so she's hanging out. Wait, let me see if I can switch the camera. There she is. Good girl. What's that? Okay. So yeah, it doesn't just have to be music. So I made a sketch in processing, which I'm surprised more people at Princeton haven't heard about, because it was really like the bread and butter of like my design program. You know, it's a programming environment, an integrated development environment that makes a lot of affordances for beginners. It's very easy. The community is very large. If you don't know anything, you can end up making something pretty cool pretty fast. So that's what I was working with. And I used it to generate some visual patterns. And what you're seeing colors and you're seeing different sized blocks. That could very easily that could have very easily have been just musical information, but instead I wanted to like visualize it in some way. By the way, the music for this isn't being generated by the synthesizer. It's just like a song that I really like that I thought fit pretty well with what I was doing here. I can't remember the artist, but if you like it, you should check out Tangerine Dream. They're pretty rad. So I'll just skip through a little bit to show you some of the patterns that I was producing with it. So one other thing to note here is that, oh wow, Brendan, this is so cool. This is what these chips do anyway, without like an Arduino and a laptop running processing doing. These chips produce like the CRT signals that were coming out of like retro computers in the 60s, 70s, 80s. Like these chips were just running very fast, and instead of like generating audio frequency, you know, through oscillation, they were generating like monitor, computer screen information by running just very, very quickly. So when you see something like this, it's very slow and it's very ineffective. But ineffective in a technical sense, you know, it's effective in like an aesthetic sense. You know, it kind of helps you understand the principles behind these chips and how they operate, and the potential for, you know, really, really beautiful, you know, inspired creations. So let's just see here. Bora Yoon asks, so this is a MIDI signal deriving the visual, and yes, it is. So like processing is receiving like MIDI note information, and then it says, what is that MIDI note? Oh, it's a high note. Okay, make the bar big, make it orange. Oh, it's a low note. Make the bar small, make it blue. And it's just a single channel of MIDI information. So that's all cool, you know, and at this point I'm in grad school and I'm kind of starving to death, you know. I'm spending a lot of my own money on these things, and I went to Parsons and it was not cheap. So I'm like, people really like these things. I'm good. Oh, by the way, like I was making these things on a laser cutter. That's kind of why I work at Studio Lab. I'm really good at using the laser cutter, really good at using 3D printers, and really good at electronics. I mean, in a beginner sense, I can help you. Or I have like some insights or different methods for fabricating that I've kind of discovered on my own. You know, there isn't like a book for this stuff. You only pick it up over years of experience, and I'm happy to share it with you. So stop in anytime or ask me a question. But yeah, I made all these things on the laser cutter, and people were like, "Wow, they're really cool. Can I buy one?" And I'm like, "Yes." So I started my own shop online. I started producing different synthesizers, different open source projects, and just making them like look pretty, because a lot of open source projects are just like really ugly. No offense to open source projects, you know, they're like real meat and potato projects, and just kind of like, hey, can I like do what you're doing except, you know, in a pretty box? And people are just like more than happy to be like, yeah, that's really great. Could you send me one? And I'm like, of course I can. So I really kind of, it was a great way to meet people online and talk to them about, you know, their project, and also make them feel really honored to present it in a beautiful package. So anyway, my whole mind kind of shifts from producing these things as like, you know, artistic objects to you know, selling them for money. And when you start thinking in that mindset, your entire brain just like changes. Like, okay, like these knobs over here, like those are expensive. It took me forever to laser cut this. These jacks are like only sold by one person, and it takes them 2 months to get here, so that's not good. I wired all these LEDs by hand. Well, that's probably not going to scale all that well. So your brain starts to like change. You're like, I got to get this thing on like a single circuit board. I have to like figure out how to use surface mount components. I have to like cram as much power, as much you know, as many features into like the smallest footprint, so that people feel like they're getting their money worth. I have to find a way to make cases that are like more durable, because, you know, this case right here looks nice, but it's not going to last on the road, you know. It's going to fall apart pretty quickly. So yeah, I got more into, yeah, you don't need to see that. So this was my next step. I was like, this is a great idea. Let's try and like make a version that like other people could have, that's like portable and easy to assemble. And yeah, my solution was to take the big jacks and make them into small jacks, and use wire instead of cable. And the other thing that I did was, instead of using the logic chips themselves, which have a pretty rigid range of what they can perform, you know, like when you give me this signal, I route it that way. And it's like, okay, well, that's kind of cool, but like, what if I could tell it, you know, instead of doing it this way, what if you just did it the opposite way? So I started designing modules with the Arduino microcontroller. I would program the Arduino chip, and then I would put it into the module, and then the module would behave based on programming rather than the physical electrochemical properties of a chip. And that really just like expanded all of the possibilities with designing modules, because now you weren't limited by the chips or what chips you used or how you combine them. You could like design your own modules and do the same thing. So this is a video showing the latest version. I designed this when I was a resident at iBeam, and I want to thank Blair Neal, who's a pretty prolific visual artist himself, who I gave this to make something with, and he made this really just like rad video with it, and just yeah, friends are great. So let's watch a little of this. So as we're watching it, you can probably hear already that this is much closer to what we were working with. The latest iteration. A lot of the same ideas, a lot of the ideas of like patterns, the sheer number of LEDs and the density of controls. The interesting thing with this is that each jack has 4 outputs on it, so you can plug 4 different cables. Basically, like every patch point has a breakout built into it, and that was like, oh, great, you know, now I want to send this signal here, here, and here. Like, that's easy now. On the other one, you could only route one signal to one place, which got frustrating pretty quickly because a lot of the modules need to be driven by the same signal in order to create like a harmonic structure across all of them. Not like oral harmonics, but kind of like aesthetic harmonics. Like kind of the way like a drum beat has like harmonics to it. You have bass drum, snare drum, bass drum, snare drum. That kind of relationship for pattern building. And also the kind of harmonics you were seeing in the colors that were being generated in the last video. So Blair did some really cool stuff. He went a little bit further and started experimenting with modules doing kind of feedback loops on themselves, where one module would be like driving another module, and like this one would start, and when it started it would send a signal to this one, and then when this one started it would send a signal back and turn this one off, but then this one over here would turn it on, and you started to realize that this wasn't just like a toy anymore, and it wasn't just a pattern generator, it was like something like deeply expressive in a way that like was different than other kinds of you know, pattern generators. Here, let me skip ahead to like this pattern that he made is just like really wicked. So yeah, I think that's one of my favorite things that I've heard come off of one of the devices that I've made. I think if you're ever interested in doing work like this, you just like nothing really compares to having someone make something really cool with your device, or have them like interpret it in a way you've never even thought of, and your mind is blown, and then you go back to the drawing board and you start designing the next version with that person in mind. Yeah, it's a really beautiful conversation that goes on between designers and performers. And yeah, myself being trained as a designer, I did like a lot of user testing. I would reach out to different people. In New York City, it was kind of easy because they were all over the place and like all of them wanted to use it, so I got a lot of great feedback. So this is the point where I really discovered that like pattern generation isn't just like a tool anymore. Like you can produce very interesting things with it, and you can feel like you made it, and that's like that's the most critical distinction to me for like what you think of as an instrument and what you kind of think of as like a tool, or like as a toy, or as something that generates inspiration. Like when you make a pattern using all these cables, like, oh, I plug this into here, I plug that into there, when you feel like you've made something that no one else could have made, that's when you start to feel ownership over it, and that's when I think it starts to cross over the line of just being like a tool or an aid for creating music and being an instrument on its own. So that's kind of that's like a loose definition. I think every instrument designer kind of has their own definition of like what an instrument is. And so that's kind of mine. I don't want to pretend like that's authoritative or like that's the way it should be, but I just wanted to share that with you. And so just to show you one of the other projects I made that I felt was very much on the other side of that line, where it was just a device for creating like neat things. This is a sketch that I made in processing again, and I used another software called Max. It's just called Max. I mean, if you're old school, you say Max MSP, or you say Max MSP Jitter, but it's called Max, and it's just like not a good name at all. So I was using Max to interpret the information coming out of it, to kind of scale it, you know, because it was mostly kind of random note information. It kind of sounded really dissonant, so I was using Max to filter those notes into like a predefined scale. So this is that. The general idea is that you get, let's see, 1, 2, 3, 4, 5, 6, 7 different sliders to control how many notes fire out of a center point, and you control the rate that they fire, the velocity that they come out, the duration of the note, how long it lasts. You also control how great the angle is with each fire, with each one that comes out. And and then this was great. This is a great feature. I think this says random, and I think this adds a little bit of noise to make it kind of different every time. So this is kind of just, we're warming up here, and maybe I'll skip ahead. No, here it goes. So now, and like, I think this is interesting. Like, this is a great sound. But really what I'm doing is just noodling with these controllers. I mean, it doesn't really, I don't feel like I've created something really, really deliberate or really precise. I'm just kind of winging it. But the fun thing with these pattern generators is that you can make patterns that are kind of similar to the way a human has made music before, or you can kind of push them to their breaking point where you start making things that haven't been heard before. So let's get to the weird part. Yeah. Anyway, I'm so happy to share this project because mostly it just kind of like gets pushed under all the like, oh wow, you made something with like blinking lights, that's so cool. And it's like, yeah, I made this other neat thing one time too. That's cool. So are there any questions? Any questions? Are we all good? Sorry, I'm kind of going on this like deep history tour. I'm sure people want to like see how the synthesizer like actually works. So that's actually an important distinction. It's not a synthesizer. It's like a very complicated step sequencer. It's like a pattern generating device. When you say the word synthesizer, it usually means audio synthesis. This does not do audio synthesis. It only does MIDI synthesis, like information synthesis, pattern generation. So it's a little weird. It's kind of a distinction. Like, I just call it a synth because everyone sees it as a synth. They're like, oh, it's got lights and it makes sound. And it's like, actually, it doesn't make sound. It just tells something else what notes to play. Okay, I'm going to share one more thing. And honestly, like, you all might be sitting there thinking, like, tell us more about the synth, you know? Like, tell us more about this and how it works. And it's complicated. It's not fun. This is my, let me switch screens here again. This is my design document. When I left my last job, I was just like, I had this idea to make this thing, and I was like, oh, I'm gonna quit my job and I'm gonna make $1 million selling this thing. And I was like, you know what I'm gonna do? I'm gonna hire a programmer. I'm gonna make a very precise design document, and they're gonna read the design document, and they're just gonna make it for me. It's gonna be the best thing ever. You know, I'll just purely do design, and then the coder will code, and you know, they'll read what I put on the paper, and it'll be fine. Yeah, it doesn't work like that at all. Really. And maybe, I don't even think it really works like that anywhere. Like, you are always going to be doing the thing you don't want to do when you try and make the thing you want to make. What was making the sound we heard? Liam asks. So in the last video I played, it's an open source VST called Piano 1, I think? Or maybe it's called Virtual Piano, but it's just got a great piano sound, or it's like a good enough piano sound. I mean, you can buy like VST grand piano sample packs that are like several $100s. But it was good, so I just used that one. I'll link it in the Slack at the end of this. It's always come in handy for me. It's kind of like a baseline to see how everything else sounds against it. But yeah, back to this. So I had this programmer and I was like, yeah, help me program this thing. And let me just scroll through this. And even this document that I made that describes how the new system works, it's only like the tip of the iceberg. I mean, there's so much that's not explained in this that you can only really tell someone about and like let them know like why these features are important or like where you can use them. And you're like, wow, this is still going on. And it's like, yeah, it's still going on. It just goes on forever. When you have like a big idea and it just sits with you for 7 years, it just like collects stuff. It's just, oh God, so much. So tonight I'd like, for my own sake, I kind of just wanted to tell you about like the story behind the synthesizer. Maybe we can do another Rad Lab where I talk in detail about all its technical specifications, or yeah, I don't know. But this talking about the story of how it was made is like so much more interesting to me. But yeah, I've got one more thing to share, and it's the version before this final one. And this was like I'd gotten out of grad school. I had my fancy fancy residency at iBeam. Up until that point, everyone who had been like an iBeam resident like went on to like glory and fame, and like by the end of it, I was just like, wow, I am not going to be a designer. Like I can just not do it. Like I cannot like pay the bills through like making ads or making like weird like interactive installations for like Nike or something. I was just like, I don't care. Like I can't bring myself to do that work. So I got a job at NYU working as like a tech manager for their game design department. That was awesome, but I was still not entirely happy about not becoming like a fancy designer. And so I took all the neat ideas I had from the last prototype that I showed you and all my bitterness and combined them into one one like monolithic form. And so this is another version of Destiny Clock, and I don't know. This video is just like out of control. It's like meant to be fancy, meant to like impress people, and it's just not my style. Basically my thinking was, okay, the yellow prototype that was about this big, like that was cool and all, but like what if I just made a huge one? And like what if I just made like everything there was on the first one, like let's just duplicate it. Like what happens when you just have a ridiculous amount of modules at your disposal? Like what would happen? The other thing, where the bitterness comes into play is that I kind of laser etched like the labels on it in this very faint, you can't read them. Like there's no manual for this thing. You can barely read the labels. The inputs and the outputs look identical. There's no color information. It's just all white LEDs. It's more of just like, and so I kind of call it like the Rosetta Stone design, because it's just this big monolithic form where it's very difficult to read. Right, okay, so Cynthia asks, did I do the videography? And I did. Yeah, I had access to a fancy camera at the time, and I shot it that way. If you want any advice on how I did that, I can show you later. Bora asks, is it 3 large modules or smaller units than that? So yeah, it's actually like maybe 20-ish modules. If you look with the mouse real quick, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I was getting more into the idea of like semi-modular. Like, what if you just had all the modules, and then me as the designer can tell you where the best position for them is. Like, hey, like just use this position. That's it. And I don't know, it was just kind of like arrogant and goofy. It didn't work at all, and it was a huge pain to wire together. I don't know what I was thinking. I was just like, let's make this thing. It was kind of like the thing that I needed to make in order to like move on. Still really impressive, but also at the same time just like a little weird. Whew, who knew I could talk this long? Let me just tell you the big thing that happened between like this kind of like slump, this like really bitter, you know, I'm not a famous designer. Here's my mean synth that no one else can play except for me. And I'm like losing interest in synthesizers this whole time. Like for the past like, wait, let me think about this. I got to think about it. For the past 15 years, like synths have just been like button matrices, like 8x8 grids with RGB LEDs behind them, and like just variations on that, and then also getting much more technical into like the kind of sampling and synthesis and like sound generation. And it was just, I just feel like synths are not moving forward, so I'm just like losing interest in them. There's nothing like exciting coming out that's keeping me excited. And so I don't know, there's like this Kickstarter for this book called Push Turn Move, and I'm like, oh, that, you know, that's kind of cool. And then it's like interface design and electronic music, and I'm like, gosh, that's kind of exactly what I do. And here's this like beautiful book on it. Like, and it's not about, you know, waveforms and like super fancy like DSP, digital signal processing. It's just like, it's just about the way it looks. And I'm like, that's kind of my jam. I have to get it. So I got it, and I read it cover to cover, almost kind of like, yeah, just, I know all these things, you know, it's just in a fancy book now. But then I saw something that I've known about all this time and never really digested it, and it just like blew my mind. It's the Moog Source, and you're like, oh, that's not really a famous synthesizer. I mean, it maybe did some things. If there's this thing called Vintage Synth Explorer or something, it's a website that tells you like a synthesizer and all the famous albums it was listed on, or it appears on. But I think at the time, people hated this thing. I mean, let me just bring up an image real quick. What's a good one? Yeah, this one's fine. So it's big. Wow, there. Thanks, Google. So let's just look at this thing. When you think about a synthesizer, you like, you know, it's called noodling. You go around the board and you twist the knobs and stuff. The Moog Source has one knob. I mean, it's got 2 knobs, but I don't even really know what this other one does. And then it doesn't even have any push buttons. It only has this membrane keyboard. And a membrane keyboard, I can't, like, some TV remotes have them, some exercise equipment has them. The Speak and Spell, I think, is the best example of something that had a membrane keyboard. It sucks. It's like your finger hurts after like maybe a minute of using it. You really have to jam your finger down and to use these things. So the Moog Source is 1 knob, and it's got a membrane keyboard. Like, wow. But what it does is you press a button, and when you press that button, it changes what the knob does. So you press the button, and when you press it, you're like controlling the filter, and then you turn the knob. And then if you press this button, you're controlling the pitch. And I was just like, oh my gosh, like, that's it. What if I pressed a button and I pressed another button, and then a link formed between those two buttons, like the same way a patch cable does on a modular synthesizer. So with this, you know, instead of having to take this cable, and like these patch cables, they're so cool, right? Like, oh, I'll plug them in, it'll be a great time, here, there, everywhere, like it's so much fun. You do this for like an hour and you're just like, why am I plugging in all these cables? Isn't there like a better way? There is a better way. And so it's this push button. Press a button, press another button. Here, let me get this on camera. A link forms. Press this button, bang, 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 and then a link forms between all of them. And I was just like, okay, I'm leaving my job now, and I'm gonna make this happen. And so that's kind of the story. I like read this book. I saw this thing I knew about all this time, and I was like, that's the idea. And that's what I did, and that's how I made my synthesizer that looks like a control panel from Star Trek. It does the same things that everything I just showed you. You know, you saw the evolution from like, let's make a real synthesizer. No, this is easier. Let's turn it into a product. No, I'm bitter. Oh, books are awesome. Bam, here we are. We made it. I didn't even get a chance to talk about how it works, but I think you all probably get a sense of how it works and like what the implications of a design like this is. And I think I've gone on like a bit too long at this point. I want Rad Labs to be kind of short, but this is something coincidentally I know a lot about, and like even just one session wasn't enough to cover it. So I'm kind of wrapping things up. Are there any other questions out there that I could answer from the Slack channel? So just let them fly now, and I'm just gonna sit here for 30 seconds as I wait for what I'm saying right now to reach you, and then you have to type it out. And yeah. A question. Want to show your favorite thing you made with this? Well, yeah, okay, so, oh my gosh. The questions are pouring in now. So I don't have a favorite thing that I've made with my synthesizer. Really, my favorite thing is sitting down with one other person and telling them all about it and seeing how they react to it. Seeing how they use it like no one else. Because it's a new instrument, there aren't really any rules. And it's kind of funny, the people that know the most about synthesizers that I show it to are actually pretty bad at it. They don't understand that it's a completely different thing. People who they don't know, they'll just be like, this is great. I'll touch this, I'll touch that. I don't care. And something really cool comes out. So really my favorite thing is just sharing it with people. That's how I like to think it exists. It's not really an instrument. It's really like this neat thing that I did that I can share with other people and learn more about them through it. So Liam asks, how do you see what your patch is? And this is where we get into the technical details, but I'll show you very quickly. There's basically 3 modes you can be in on this thing. You can be in patch mode, which we're in right now. You can be in play mode, where you can basically like press, you press buttons, and when you press them, it generates that signal. Like pressing the button is analogous to having something patched to it and a signal generated to it. And the last mode is edit mode. See, it says right there, it says edit. And edit mode shows you every point on the device that has something patched to it. So everything that's lit up right now, there's a patch cable there. And when you press one of those, you get to see what it's connected to. And when you're here, you can press it and then boop, and that gets rid of the link. And then let's see if I have, okay, so this one down here, I press it and it's actually patched to 2 things. These 2 signals come down to here. These are all out, well, everything that's white, oh, ignore this part. Everything that's white is an output. Everything that's black or has a color to it is an input. And down here, everything is inputs. So if you have 2 outputs going to an input, they are automatically put through an OR gate. basically if either one is on, the input will receive that signal. Mensch asks, will you produce the next lo-fi beats for studying with this? And yeah, you can crank out jams very quickly on, without really trying. It's hard. It's hard and it's easy. You know, you get satisfaction immediately, which is kind of the thing that draws you in deeper to make more complicated patches. But yeah, you can crank out music very quickly, feel very good about it. And so yeah, when we're back at Princeton and when there isn't a global pandemic and we're able to no longer socially distance, yeah, any of you who want to play it or experiment with it or ask me questions about it in person, like we can hang out and we can do that. But right now it's a little difficult. um yeah, let's see. Cynthia, thank you for saying get YouTube famous with your tunes, Brendan. I appreciate that. Yeah, I am YouTube famous, by the way. I have 400 followers, not on this channel but on another channel. Bora asks, do you remember the MC505 Groovebox CD that came with the synth? And I don't think I do. MC505. I think I remember what it looks like. Cool. They essentially gave the machine to all these artists to see what they would create with it and released it. I can see something like this happening with this, just like Dan Truman's Bitklavier software he's doing now with various composers and players. Yeah, so I've thought about that too a lot. Basically, it's like if the synth is in the right hands, it will do incredible things. And you didn't ask the question, but my dream performer to get this in the hands of would be Tyondai Braxton from Battles, who actually has his own project now involving a lot of synthesizers. I know if you know anything about the synth world, there's this guy Richard Devine, who I think people think of as like, if he buys my thing, then you've made it. He basically has one, maybe two of like everything. His studio is insane. That would be, it's not like a super goal to like have him play it, but if he buys your thing, you're kind of like, well, I'm part of the club now. I'm official. But I think Tyonde Braxton of Battles would be a really cool person to experiment with this. Susan Ciani would also be pretty awesome. Those two people, I think, have a blast with this. And yeah, so I may have made some promises during the video, like, oh, I'll drop this link in the Slack. I think I forgot what those promises were, so please feel free to send me a message and be like, hey, remember how you said you would do this? Like, yeah, I'll do it, but I forgot, so just ask me again, and I'll put that in the Slack channel. I'll also drop a link to my YouTube channel, and like there's more videos of me doing synthy stuff. I've got some experiments that I did on my SoundCloud using the device, so you might enjoy those. But I think we're pretty much like a Rad Lab 2 for talking about how this actually works. I'm sorry, I was like, well, I should do 50-50 tonight, but then I got rolling, being nostalgic about old times. But that's it. I think that's it. So I think I'm going to sign off. We haven't really figured out how to close Rad Labs yet. One last thing I want to say about Rad Lab is that you can do one. We would love to have you do a Rad Lab. It's not a big deal. I mean, you just get your webcam, sit in your apartment, and like tell us about something you're really passionate about. I went on and on for about an hour, but if you just want to talk for like 15 minutes about something, we would really like that. And it doesn't have to be fancy, it doesn't have to be polished. It just has to be something that you find interesting, that you think other people will also find interesting. And I will come to your Rad Lab. I'll be in the chat asking you questions, seeing how things are going. So you can count on me attending. But other than that, this is very much like a prototype. We're gonna work on this over the summer, and hopefully by the fall we'll have like a really good momentum. Maybe we'll have some fancy graphics. Maybe we'll have like a very clear statement of what Rad Lab is, but mostly right now it's just us figuring it out. And if you want to figure it out with us, we'd love to have you on board. And so that's it. Thanks a lot for coming tonight, and I'm just really glad I got some great questions, and that's it. I'm gonna log off now, but I'll be hanging out on the Slack, so feel free to ask me questions there. Okay, bye.